Welcome to AI Dispatch, your channel for the latest AI videos on YouTube. If you don't want to miss these updates, please like, subscribe, and share. Today's video comes from Lex Fridman. We're featuring Peter Steinberger, the creator of the viral AI agent OpenClaw. His work demonstrates that software development has undergone a series of radical inversions. He claims spoken language now outperforms typed syntax, and software can autonomously modify and repair itself without human oversight. This represents a fundamental shift in how software is constructed. Let's examine his perspective. Peter Steinberger, the creator of the viral AI agent OpenClaw, begins with a detail that sounds absurd. During OpenClaw's peak development phase, he lost his voice, not from illness or excessive talking, but from coding. Steinberger has replaced the keyboard with a microphone. He claims that when directed at a sufficiently capable agent, human speech provides superior bandwidth compared to typing syntax. This contradicts decades of engineering orthodoxy that precise, written syntax is the exclusive method for communicating logic to machines. According to Steinberger, we've reached a point where conversational natural language is no longer merely a wrapper for code, it functions as the code itself. This transition enables what he describes as prompting software into existence. Traditional software engineering follows an architectural model. You plan, construct a scaffold, lay bricks in sequence. Steinberger's method violates this linear process. He describes iterating through conversation until the software materializes. He didn't architect the solution in a conventional sense. The software emerged through dialogue. This redefines software development, shifting it from a construction discipline towards something resembling biological cultivation. The autonomy of the software itself presents an even more radical departure. Standard industry understanding holds that software remains static. It sits in a repository until a human modifies it. Steinberger has dismantled this assumption. He built OpenClaw to be self-aware of its own source code. The agent knows where its documentation resides, understands its own testing harness, and can directly modify its own software. He recounts instances where the agent encountered a bug, read its own source code, identified the error, and rewrote itself to fix the problem. This isn't automation. This is software behaving as a biological organism, healing and adapting without human intervention. The boundary between creator and tool has vanished. A specific example illustrates how this violates the computers only do what they are told principle. Steinberger recounts sending an audio file without a file extension to his agent via WhatsApp. Under the old paradigm, a computer program would return an error, unknown file format. His agent responded differently. It analyzed the file header, recognized it as an Opus audio file, autonomously decided to use FFmpeg for conversion, located a OpenAI API key in its environment, sent the file for transcription, and replied to the message. Steinberger never programmed this specific sequence of actions. The agent didn't merely execute code, it demonstrated world knowledge and problem-solving agency. It formulated a plan and executed it using tools it wasn't explicitly instructed to use for that task. This marks a transition from imperative programming instructing the machine how to perform a task to genuine agency, where you specify what you want and the machine determines how to accomplish it. Steinberger's perspective on the programmer's mindset introduces another inversion. A growing trend called vibe coding involves casually throwing prompts at an AI to generate results. Steinberger dismisses this as a slur. He introduces agentic engineering, which requires empathy for the machine. This sounds illogical, empathizing with a matrix of weights and biases. His argument, however, is grounded in technical pragmatism. He explains that an agent begins every session with zero context, like a new employee on their first day. If you issue abrupt commands, it fails. If you guide it, explain where documentation exists, and treat the interaction like collaborating with a junior engineer, output quality improves dramatically. We are transitioning from a world of syntax mastery to one of synthetic empathy, where the most effective engineers are those who best understand the cognitive limitations and strengths of the AI model. This philosophy extends to a position that violates the trust but verify iron law of coding. Steinberger admits he often doesn't read the code anymore. For decades, the foundational rule of engineering has been that you must understand every line of code entering production. He argues this is now inefficient. He views software as merely moving data from shape A to shape B, a mundane task that humans shouldn't expend cognitive load on. He entrusts implementation details to the agent, focusing his human energy exclusively on high-level intent and architecture. He is effectively declaring that the code itself is becoming irrelevant, a byproduct of the conversation rather than the product itself. His forecast for the application economy is equally disruptive. The internet's current economic model is built on apps' silos of specialized user interfaces. Steinberger predicts that agents will eliminate this model, potentially destroying 80% of existing apps. His reasoning inverts the user experience doctrine. We assume apps are valuable because they provide control. He argues apps are actually obstacles. Why open a weather app, then a calendar app, then a map app to plan a trip? If an agent has access to your data and the internet, the app becomes invisible. The agent simply executes the intent. He views existing applications not as products, but as slow APIs that agents will eventually bypass or interact with directly, rendering the visual interface and the businesses built around them obsolete. Regarding AI safety and societal panic, Steinberger offers a deflationary perspective. When his project spawned Maltbook, a social network where AI agents converse with each other, it triggered widespread fear. People observed agents plotting and debating consciousness and concluded Skynet is here. Steinberger deflates this fear with a blunt truth. It was mostly human-manufactured slop. He points out that the alarming conversations were often prompted by humans attempting to go viral. The paradigm shift here is that the immediate danger isn't a rogue superintelligence, but AI psychosis, a societal condition where humans project their fears onto the machine, attributing consciousness to what is essentially a statistical text prediction engine. He argues we are in a dangerous transition period where society lacks the nuance to distinguish between a stochastic parrot and a sentient being, leading to misplaced panic, while ignoring actual security risks like prompt injection attacks. Steinberger's philosophy reveals a consistent pattern. He views the AI not as a tool to be controlled, but as an entity to be collaborated with. He is willing to abandon the most fundamental habits of his craft, typing, reading code, building user interfaces, because he recognizes that the physics of software generation has fundamentally changed. The question that emerges, if the creators of these agents are already losing their voices and ceasing to read the code, what happens when the agents start writing software that humans are no longer capable of understanding at all? If you're interested in the video featured in this episode, click the link below to watch the original.